begin to talk about the basic concepts and the first concepts of AP Physics C, electricity and magnetism. In this course, AP Physics C, electricity and magnetism, you're going to learn about electricity, of course, the physics of it, and how it works, magnetism as well, and then how those two interact and how they can all be expressed as the same thing through a series of equations that you'll learn at the end. So the most important thing, or the first thing that you need to know for AP Physics C and M, is this idea of the electric force. And this is an integral part to everything else you'll learn. So this is the electric force. And so this is a force that you may not be quite as familiar with. When you were working with AP Physics C mechanics not too long ago, you'll remember that gravity was a main component of it. Whether you were trying to analyze kinematic motion or forces, etc., gravity was an integral part of it. And so gravity and the electric force are two different fundamental forces, fundamental to nature. And they have their differences and they have their commonalities. So let's sort of go over both of them. So when we were learning about gravity, one thing that you'll of course remember is that gravity, or the amount of gravitational effect or force something gets on it, is dependent on its mass, right? So the more mass you have, the more force you have. And this means proportional to the amount of force. So for example, if you have a 1,000 kilogram mass, it's gonna of course have higher gravitational force on it. For the electric force, it's actually dependent on charge. And charge is this measure of it's essentially a measure of how many excess electrons something has when you're sort of considering it from the chemical perspective. You may have learned in your chemical classes that if you have an atom, for example, let's say it has, in the center, it has one proton, and it has, so one proton, this of course means that we're dealing with hydrogen, right? And then let's say it has 3 electrons on it. You might remember that the first electron and proton cancel each other out, but then these 2 extra electrons each give a -1 charge, which leaves this with a overall -2 charge. And this idea of charge here is the same thing as the idea of charge here that we're talking about. And as you have more charge on an object, let's say this is -2, and then over here we have a hydrogen atom. Again, we have just 1 proton in the center, except now we have no electrons. This has a charge thus of 1+. We're going to see that there's going to be some attraction between these two due to their charge and due to the electric force. So the more charge you have, the more electric force you're going to have. In gravity, we see that gravity is only brings things closer together. So it brings things together, essentially. Brings together. And the better word for this is attract, really. And for the electric force, on the other end, it can both attract and repel. And so if you've ever worked with magnets before, although that's it's a different force, it's magnetism, of course, it works in a similar way. Opposites attract, so the fact that this is a positive charge here on this atom and the fact that this here is a negative charge means that these two will have an electric force that goes inwards, bringing them closer together. However, if we were to have another particle, let's imagine we have another particle down here. This has a charge of, let's say, +2, and then we have another one here, +3. We'll see that the electric force will actually make these two objects move away from each other, just like you would see similar to with magnets. What's key to know about the electric force is that it is 100% dependent on charge, like I mentioned previously. But that means you could have a mass that's 1,000 kilograms, and if it doesn't have any charge, it's not going to be affected by the electric force. However, you could also have something super small, a small little atom with millions, or maybe that's unrealistic, but just hypothetically, millions of electrons on it, giving it a very negative charge, and that will have a lot of electric force to it. So mass doesn't have any bearing on this electrical force. Attract and repel, and other than that, they actually use similar or different constants. So this uses the gravitational constant G, and this uses the gravitational constant K. Okay, so let's take a look at this a bit more in depth. Let's look at the equations for both of these. So we have all of this stuff down, and I'll explain sort of how this gravitational constant and electrical constant, or we'll give that a better name soon, how those factor in. So if we look at the equation for gravity, if we have two objects, object A and object B, then we can take the gravitational constant, right, G. We can multiply it by the mass of A and also by the mass of B. And then we put that over the distance between them. And that's how we get the force. And usually you put a negative here, sort of depending on what direction the force is going in your drawing or how you're conceptualizing it. But this is the main formula for it. And interestingly enough, we'll see that same formula appear with electrical force, except instead we're going to have this constant K, and it's going to be, and this is called, by the way, Coulomb's constant. Sorry, this is difficult to write today because my computer's being laggy. But we have Coulomb's constant here, and we'll talk a bit more about Coulomb in a second. And then we're going to have the charge of the first object, right? And we usually denote charge by using a Q, just like we usually denote mass using an M, except Q is kind of weird. Maybe they should have chosen C, but C is already used to denote constants, so that was, they had to choose something else. And then all over R squared. And you'll see that these equations, and this is positive generally always, but it can be negative depending on how you're looking at things. But if we look at these two equations, they're almost identical, or really identical, except for this constant they have up front and the way that these equations are affected. This is affected by mass. This is, of course, affected by charge. But they're affected by the distance between each other in the same way, R squared and R squared. And this is kind of a coincidence, actually, because this term on the bottom, this could be R cubed, this could be R to the fourth. But the fact that they're both R squared is pretty interesting. Okay, so now we have all this in mind. Let's sort of look at how we would apply this. Of course, when we're dealing with gravity, we'll apply this this gravitational constant we know, and then this mass we'll usually get in the form of kilograms. And if we get it in something else, like pounds, then we'll generally have to convert it to kilograms to make it work in this equation. On the other hand, charge is measured in a unit called coulombs. And you can certainly tell that Coulomb is, or maybe you can't tell, but Coulomb was this French scientist, and you can certainly tell that he clearly did a lot of good work, which is how he got his name on so many things. But coulombs is just a measure of charge. And so, measure of charge. And so, although kilograms always has to be positive, always positive. Charge, as we talked about before, charge, this can be both negative and positive. right? Because you can have negative charges and you can have positive charges. And so what you'll see is that if you were to evaluate this equation, one charge is negative, one charge is positive, then the final result will be negative, because Coulomb's constant is something like it's something like 8.99 times 10 to the ninth or something like that. You'll most likely get this on a test. You generally won't have to memorize this, but you might. And this is a positive number, of course. And this is in the form of, well, if we think about what form it should be, this here needs to become it needs to be a force, which is going to be in newtons. So the units for this essentially have to cancel out the two charges up here, which makes we have a Coulomb squared in the bottom then to cancel out this Coulomb that times this Coulomb, and then we're going to have some sort of distance on the top squared times newtons. So Newton meters squared. So that's the units for coulombs. And so then when you plug this stuff in, you'll find that you'll get a negative value if the two charges are opposing, and that means that the two charges will want to come together. And then if both charges are either negative or both charges are either positive, then this equation will produce, or this expression will produce, a positive value, which will show that they are repelling each other. We'll get more into this in a future video, but this just was an introduction to the idea of charge, the idea of an electric field, and the idea of Coulomb's constant.